9.7, we're going to go over area and perimeter of similar shapes. So today we're going to be using ratios of similar figures to calculate the area or perimeter of a similar shape. And remember, when we're doing a ratio, the shape we're going to goes on top, and the shape we're going from goes on the bottom. So 2 goes on top. So we kind of remembered that by they both started with a T. Shape we're going to goes on top, and then the one we're going from is on the bottom. So if you remember that, your ratios are always going to be correct. So our first example, we're going to find the ratio of the red to the blue shape. So that means for our ratios, blue is going on top and the red is going on the bottom. And we're going to do this for the perimeter and the area. And if we were to do the perimeter, we know these are rectangles. So the perimeter is all 4 sides added together. We have 3t and 2t here. And we know the blue is going to go on top. So if we take 3t plus 2, that's going to be 5, 6, 7, 8, 9, 10. So the ratio of the perimeter is going to be 10t over, if we add up on our second one, we have 3, 4, 5, 6, 7, 8, 9, 10. So on the bottom, we would have just 10. So the ratio of the perimeter is just t, which is, as you notice, the variable we are multiplying by, which also would be considered our scale factor. And then if we were going to do the area of the blue shape would be 3t times 2t, which would be 6t squared. And then on the bottom, we would have 2 times 3 of 6. So when we're doing the perimeter, we're just going to have that scale factor. And then when we're doing the area, we're going to have that scale factor squared, which makes sense because area is units squared. And perimeter is just our units. So now let's do some examples. Or one more thing first. If 2 polygons are similar with the lengths of corresponding sides in the ratio of AB, then the ratio of their areas is A squared to B squared. So when we're drawing our ratio for perimeter, it's just going to be the length of those side lengths over each other. So this one would be going to polygon 1. And this would be our ratio for perimeter. Then our ratio for our area, we just have to square those numbers. And then we can use that to find the area of a second shape. Now let's do some examples. In the diagram, triangle ABC is similar to triangle DEF. And we're going to find the indicated ratios. And we're going to find the ratio red to blue of the perimeters. So that means our ratio, blue is going to go on top and red is going to go on the bottom. And when we find the ratio of the perimeters, we just have to have those corresponding side lengths. And if we look, BC corresponds with EF. So we just need to write a fraction with those side lengths. Our side length of the blue is 12 over, and our side length of the red shape is 8. And don't forget to simplify your fractions. And both of these numbers are divisible by 4. So we would get 3 over 2. Now we need to find the ratio for their areas. And now, because it's areas, we're going to have the blue value squared on top and then the red value squared on the bottom. So we already know that we're going to have 12 over 8. Now the only difference, because we're working with area, we're going to square those values. So we would have 144 over 64. And then we can grab out our calculator to simplify that fraction. 144 divided by 64 fraction. So that would be equal to 9/4. And you'll notice that 9/4 is just our ratio of our perimeters squared. So if we just wanted to square 3/2 to get our area ratio, that works as well. Then we wouldn't have to simplify. All right, let's do another example. We are installing the same carpet in a bedroom and den. The floors of the rooms are similar. The carpet of the bedroom costs $225. Carpet is sold by the square foot. How much does it cost to carpet the den? Okay. So first thing, they tell us that the carpet is sold by the square foot, which implies we're working with area. So we're going to set up a ratio of area. And we can set this up with any one that we would like on top. So we can do the den over the bedroom. And remember, when we're doing area, we're going to square those values. So the den, they give us a side length of 14. So we're going to have 14 squared over the bedroom. The corresponding side would be 10. So if we go ahead and simplify this, we would get 49 over 25. So this is our ratio of our areas. So that was step 1. Found our ratios. Step 2, now we're going to set up an equation. So they told us that the floors of the rooms are similar and the carpet for the bedroom costs $225. We want to figure out how much the carpet for the den is going to cost. So step 2, we're going to take that ratio of 49 over 25 and we're going to put it equal to the ratio of the cost. So we know the cost for the bedroom was $225. So our bedroom was on the bottom. $225 is also going to go on the bottom. And we're looking for the price of the den. So the ratio of the areas is going to be equal to the ratio of the cost. And this is another example that would be a good one to review because there might be another one on a quiz or a test. Once we have this set up, we can solve by cross multiplying. So we're going to end up with 25x equals, then we would take 49 times 225 equals 11,025. Get x by itself, and we will end up with x equals $441. And that is going to be the cost for the den, which makes sense that that is greater than the cost of the bedroom because the den is bigger than the bedroom. Okay, moving on to our next example. A large rectangular baking sheet is 15 inches long and 10 inches wide. A smaller pan is similar to the large pan. The area of the smaller pan is 96 square inches. Find the width of the smaller pan. Okay, so first let's draw a picture. We know we have this larger rectangular pan that is 15 by 10 inches. And we know there's going to be a smaller one in here that's similar. And the area of the smaller one is 96 inches squared. We want to find the width of the smaller pan. So to do this, we're first going to set up a ratio with the areas. And we're going to do that because even though we aren't given the area of the bigger pan, we can find it by multiplying those two together. So we know the area of this is going to be 150 inches squared. So if we set up a ratio with the area, we could do 96 over 150. And we can go ahead and simplify that as a fraction, and that would give us 16 over 25. So that's the ratio of the areas. And remember, the ratio of the areas is equal to the side length of the smaller pan squared over the side length of the larger pan squared. So to figure out the area of the sides, we are just going to take the square root of the area ratio. So let's write that down, square root of area ratio. And we know the area ratio is 16 over 25. And when you're taking the square root of a fraction, you're just going to take the square root of the top and the bottom separately. And we should know the square root of 16 is 4, and the square root of 25 is 5. So the ratio of the sides is going to equal 4/5. And we're looking for the width of the smaller pan. And they told us that the width of the larger pan was 10 inches. So this is going to be the corresponding width of the smaller pan. So if we do x over 10, that ratio is going to be equal to the ratio of the sides of 4 over 5. Then we will cross multiply. We will get 40 equals 5x, divide by 5, 8 equals x. So the width of the smaller pan is going to be 8 inches. So these ones are kind of a few steps. You have to work through the process to get the information we need in order to find our answer. One more example. The floor of the gazebo shown. Oh, we don't have our picture. Anyways, the floor of the gazebo is a regular octagon. Each side of the floor is 8 feet, and the area is about 309 square feet. So we know the side is equal to 8 feet, and the area equals 309 feet squared. Okay, you build a small model gazebo in the shape of a regular octagon. The perimeter of the floor of the model gazebo is 24 inches. So the model perimeter equals 24. They want us to find the area of the floor of the model gazebo to the nearest tenth. So area is what we are looking for. Okay. You know what? This one might actually be kind of difficult to do without a picture. So we're just going to go ahead and skip this one. But if you have any questions on the previous examples, just let me know and we will get those answered for you. And that should be everything you need in order to do the homework for today.